Coach Curtis here again. We're going to talk about interval notation today. Now right now y'all are having some major problems with this, so we're going to take just a little bit of a second up here on the whiteboard in order to talk things through. Let's say that you've got a number line, okay? And we're talking about all numbers on this number line, but you want to talk about a specific group of numbers. So let's say we're talking about all numbers that are less than the number 5. Okay, 4, 3, 2, 1, 0, every negative number ever. All numbers less than 5. First off, what you need to understand by intervals is that we're talking about a group of numbers here, not just one number, but a whole range, or in this case, an interval of numbers. Now, in order to understand interval notation, you need to understand the symbols that that particular notation uses. So it's going to be one of the following, okay? The symbols that you're going to see in interval notation are either going to be parentheses or brackets or some combination of the two. Now with inequality notation, what you're dealing with instead stands to reason are inequality symbols. So things along the lines of less than, greater than, less than or equal to, and greater than or equal to. One of those 4 symbols. Now let's say what we're dealing with has an open interval. What we mean by this is that it doesn't include the number 5. So if I want all numbers less than 5, is 5 going to work? No, because I've got to have numbers that are less than that 5. So let's take a look. Using interval notation, all numbers less than 5 are going to be represented this way, by saying that it's going to be from all numbers from negative infinity up until I get to 5. So the way that you read this is all numbers but not including negative infinity. Okay, what's represented by that left arrow? Up until I get to positive 5, which is exactly what my number line looks like. Now if I were going to do it using inequality notation, I would just simply start with the 5 and say, well, my values that are going to work are all numbers that are going to be less than 5. And that's all there is to it. With inequality notation, we're based upon x, okay? Where is it in relationship to 5? When we deal with interval notation, I want to know what is the left boundary and what is the right boundary. So intervals have boundaries. The inequality notation just has to deal with the direction. We're going to switch things. What if we have what's called a closed interval, meaning that the number 5 could be part of our answer. So now we're dealing with all numbers less than 5 or equal to 5. Could be one of the two or both. So dealing with interval notation, keeping in mind, we're dealing with the boundaries on the left side and on the right side. So let's take a look. My left boundary on interval notation is still at negative infinity. So everything about that is going to stay the same, keeping in mind that we use parentheses because you never actually reach negative infinity. You can always get to lesser numbers. Now when I go to the right boundary, I'm at 5, but look, because it's closed, I can include it. The way we do this using interval notation is to still put that 5 there, but now we use a bracket. This tells us that it includes 5. This one tells us that it does not. Now going over to the interval notation, the same thing. I'm concerned with the direction that I go on that number line. So it's still going to be where x is less than 5. But now it's also going to be where x is equal to 5 as well. So x is less than or equal to that 5. Now what about if the boundaries were different? What if I wasn't using negative infinity or positive infinity, and I was actually using numbers on that number line? Well, check this out. What if I was trying to find all of the values that were in between negative 3 and 5? Okay, so I'm going to shade this middle region right here. Well, remember, with interval notation, we're dealing with the boundaries of what actually separates those two parts. So if I did not want to include, okay, negative 3 is not a potential answer, positive 5 is not a potential answer, but I want to talk about the boundaries. Well, I say that it doesn't include negative 3, and it goes all the way until I get to 5, but it doesn't include that either. So now I have the interval notation. On the inequality notation, I would be dealing with all numbers in between -3 and 5. So x, or my potential solution, is less than that 5. But it's also greater than that -3. Now, there's only one small difference if it includes one of those values, and that's if we ever have a closed interval. So let's take a look at how it's going to change depending. Now let's say I had a closed interval at -3. -3 was now part of my solution set. Well, in this case, I still have the boundaries of -3 and 5. At the 5, it's open, so I will not include that and use a parenthesis to show that that is the case. Moving to the -3, I now have a closed interval. So to show that that is a potential answer, I'm going to bracket that side off, which lets everyone know -3 is an answer, but 5 is not. Now, with the inequality notation, we're going to write it still the same way because the shaded area is in between -3 and 5. The only difference, -3 is a possible answer, so it could be equal to the -3. That is literally the only difference between the two. What if both were now closed intervals? Well, if I shade in the interval at 5, what this number line tells me is that now all numbers in between -3 and 5, as well as -3 and 5, could potentially work. Inequality notation, this is simple. I just put another or equal to line, and I'm good. X can be any number in between -3 and 5, but also equal to those two boundaries. Now with the interval notation, I only need to make one small change. It's already equal to -3, but now, as opposed to using a parenthesis to show that it's open at 5, I use a bracket in order to show that that 5 is also included in the answer set. Now there's only one other situation you need to know, and that's if your solution or your shaded area on the number line is to the outside, okay? What if it's a compound situation where it's all numbers less than -3 and all numbers greater than 5, but not what's in between? Well, here's what you do. Remember, interval notation deals with boundaries. So take a look at the left side. The left boundary is at the left arrow, or -infinity. And the right boundary for that segment, or that interval, is at -3. It's not open, or excuse me, it's not closed at -infinity, can't ever be. And it's open at -3. Now I'd also need to put down the interval to the right side. So that leftmost boundary is at 5. And the rightmost boundary is at the right arrow, or positive infinity. Positive infinity is always open, and at 5, it's open here as well. Now, with the inequality notation, x, or my shaded area, is all less than -3, or greater than 5. Now, once again, there's only one small change if it becomes closed intervals at either of those numbers. Let's say that now -3 and +5 are potential solutions on our number line, okay? They're closed intervals. They work. Let's see how it changes. Now, over with the inequality notation, it's simple. What little symbol did I add to the bottom of each of these inequality symbols to make this true? And or equal to line. Now x is all numbers less than or equal to -3, and x is greater than or equal to 5. And with the inequality, the interval notation, everything stays the same except for the symbols we use at -3 and at 5. And -3, it was open, hence the parenthesis. Well, now that it's closed, I'm going to put a bracket at -3. 5, it was open, but now that it's closed, and 5 is a possible answer, I'm going to put a bracket at 5.